Hello everyone, welcome back. So in this video we're going to talk about chapter 3 in the Helicopter Flying Handbook, which is probably one of the shortest chapters. It's a little bit about helicopter flight controls. We've briefly mentioned these flight controls in the previous videos, but wanted to cover them in a little bit more detail. So that's what we're going to do now. So, what are the various controls that you might have in a helicopter? Well, the first control we're going to talk about is the collective. So, the collective is located to the left of the pilot. Now, by the way, if you're flying an airplane and you're flying from the left seat or the right seat, it's like a huge difference because you have to use a different hand for the controls. Helicopters, however, don't have this problem. So if you're in the right seat of a helicopter, which is typically where the pilot in command sits, it's reversed from airplanes, you still have the right hand on the collective, or the cyclic, and the left hand on the collective. If you sit in the left seat, guess what? Same thing. So the collective, if you lower it, it decreases the pitch of the main rotor blades, produces less upward thrust, and you're going to sink. If you pull it up, it increases the pitch and you go up. It's really that simple. So that is the collective control. Now, the throttle is typically, for a piston-powered helicopter at least, on a twist grip. So if I twist it up, or as viewed from behind, I guess that would be counterclockwise or anti-clockwise if you're British, it's going to increase the throttle. So it works just like a throttle on a motorcycle. So the direction that you would twist the throttle, I guess it's all relative, really. But it does work like a motorcycle twist throttle. Now, typically, there will be, as we said before, this thing called a correlator. And what does the correlator do? As I lift this, it mechanically increases the throttle. And that's going to do 80% of what I need to maintain my RPMs correctly. Now, some helicopters, like the Robinsons, also have a governor. And that governor will actually just keep the RPMs where they have to be. So in a helicopter that doesn't have a governor, you might say, well, I don't know what to do. Well, here's what you do. If the RPM is low and your manifold pressure is low, you should probably increase the throttle, which increases the manifold pressure and the RPMs. If your RPMs are low and your manifold pressure is high, you need to lower that collective. You're trying to do too much. So that's going to decrease the manifold pressure and it's going to increase the RPM. RPMs are too high and the manifold pressure is low, raise the collective. And if they're both high, reduce the throttle. That's how you fix it. Okay. What about this other control, the cyclic? Traditionally, your helicopter is going to have The cyclic stick might look like this, where it's kind of curved and it's between your legs, and there's one on each side. The vast majority of helicopters are built this way. You can see this one has a couple of buttons, and it has a hat switch. This hat switch is often used for trim. And then there's the Robinsons that are always a little different. They have this T-bar, and it just tilts. So what's the plus side of the Robinson? It's a little easier to get in and out because you can just tilt this thing out of your way. You don't have to crawl over it. The downsides, if you're unfortunate enough to be a Robinson CFI, your student is flying with this helicopter that's very touchy on the controls. So you move the controls very little, and they have this thing down in their lap, and this is hovering like 6 inches above your lap. So if you have to do anything, you have to be able to somehow reach up and grab it, and you can't base your arm very well off your leg, which is something you do very commonly with the Robinsons, in order to stabilize your inputs. So it's a little rough being a Robinson CFI, and that's a reason why the Robinsons have all these special rules on them, and you have to get some training before you can set foot in the thing for your first flight. You have to have 20 hours of instruction before you could ever solo it. And the list goes on and on. You have to have yearly flight reviews instead of every 2 years, and it's per model. So you have to have one in a 22 and another one in a 44. And if you want to instruct in it, you have to have 200 hours and 50 hours in each model. And the list goes on and on and on and on with the Robinsons. But they do have this nice tilting cyclic control that makes it easy to get in and out. So there is that. And then we, of course, have our anti-torque pedals. They work like rudder pedals. Now, one thing that's a little bit different, these move differently. It's like they're hinged down here. So they go back and forth, whereas airplane rudder pedals don't go back and forth in an arc. They go pretty much straight in and out. So if you do things like flight simming and you have different controls, you probably, ideally, you wouldn't use the same set of pedals for airplanes as you would for helicopters. You would probably want to get a different set. And I actually have a different set that I use for my flight sim. And also another difference is there's no brakes because most helicopters don't have wheels. There are wheeled helicopters, but that's not the norm, especially for a training helicopter. Typically just have skids instead. So what happens when you push those pedals, you change the pitch of the tail rotor, and that causes the tail to swing one way or the other. It's really that simple. Okay, so that's the shortest chapter in this whole book. It's a little bit about helicopter flight controls. So we will see you in class, and we'll also see you in our future helicopter supplement videos. So have a good one.